Good morning, people. Yuga, good morning. Kriti, good morning. Anuja, good morning. Achal, good morning. Ishwari, good morning. Achal, another Achal, okay. Good morning. Muskan, good morning. Harshada, good morning. Aditya, first of the boy students. Aditya. Ashutosh, good morning. Purnima, good morning. Praveen, good morning. Swarada, good morning. And Prachi, good morning. Asmita, good morning. Viraj, good morning. Okay, very good morning to all of you all. Actually, I'm sorry that I had promised you all that I would be Harshada, good morning. I would be going back and just checking about the lag or buffering, yeah, that happened yesterday. I was not able to go because I was a bit busy with other things in the college yesterday. So unfortunately, I've not gone into those details. Just in case you have identified any questions for yesterday, yeah, Tejas and Sandesh, good morning. If you have identified any questions for yesterday, you could let me know about this right now, and we could just try to solve it as well. Just in case you had questions, basically because today I'm going to shift to some other topic. Yes, till yesterday we were discussing about the geological time scale. In fact, we went into a higher level of revision as far as the geological time scale was concerned yesterday. Maitri Patel, good morning. Harshal Shinde, good morning. Uh, Today I would say I would like to share with you all that as far as your and FYBA and FYBSc syllabus is concerned, it for some time it goes parallel. Okay, and let me tell you, still till what we did yesterday, I had been sharing it with both Radhika. Good morning. I had been sharing it with both of y'all. That's the FYBA class and FYBSc. Today's class would be probably the first of the class for this particular, say, for your class, that is, which would be exclusively for the students of FYBA. Because if I compare the syllabi of FYBA and BSc, it is from here that it slowly starts going away from each other. We do things in a bit of detail, I would rather say, while as far as FIBA is concerned, they don't go into that much of detail. Secondly, we have a bit of science orientation when we start moving towards the detailing of geomorphology, which is partially there, but not as in detail, as I said, not as in detail as we would be doing here as such. And with that extent, um, I would say that what we are doing as probably the first or second topic, let us say second topic, lithosphere for BA, is actually a full paper for us. So you can understand now what the difference is. Sakshi, good morning. Ajit, good morning. What the basic difference is. Okay, we would be going further into detail as far as understanding while what they call as lithosphere and study of lithosphere, and we also have identified lithosphere, but our paper is around the mechanics of lithosphere, and that is called as geomorphology. And in fact, we are going to take up that. What is geomorphology as such? It is basically, I would like to say here that it's basically the science of landforms. Okay, because we are in FYBSc, I probably would not be saying this for uh, a BA class, but yes, for science students, I would definitely say that it's a science of landforms. Okay, where G, that's GE to start with, the geomorphology is land. Morpho is basically the process, and logy obviously means the study as such. Okay, so the land processes. Okay, is what Anjali Kumari, Mayur Bhosle, and Anjali Gorwe. All of you, all, good morning, welcome. Uh, so it becomes interesting, and many a times I have seen that many students don't get that serious about these initial topics. Yes, I would say that it's not always the students. At times it is the teachers who are also to be blamed when they don't actually make the initial topics that interesting. So the nature and scope part of each of the subject, it could be any, it could be geography, it could be chemistry, it could be physics, biology, mathematics, whatever it is. Actually, I would say that, Chinmay, good morning. I would say here that uh, nature and scope, it's my personal feeling. I still feel that technically it should be the first topic, but my personal feeling is that you get to the nature and scope of a particular subject only when you know a considerable amount of that particular subject. That is one of the reasons possibly that students are not interested in the first topic, that is nature and scope. Vishal, good morning. Um, and possibly that is a controversial reason why we students don't have that much of interest in that. I would like to, going by the syllabus, I would be required to take it up, but then I would like to simplify it to such an extent that even if we are taking the nature and scope part of geomorphology in our initials, in one of the first, Rasika, good morning, one of our first lectures. Okay, I would like to, I would assure you that I would like to make it interesting enough. And having said this, we have literally been meeting for what now, 3 to 4 weeks, and we have done considerable amount of geography, is what I feel, and I have transferred to y'all. We know what physical geography is. We know what human geography is. You are doing, Gaurav, good morning. Um Gauranga Academy Online. Okay, that's good. Anyway, whatever it is. Um so it's not that we are starting all of a new and it's the first lecture and immediately I start with the nature and scope as far as geomorphology is concerned. We have done a significant amount of groundwork, I would say, before I am taking this lecture of yours. Okay, so when we start with geomorphology, okay, what exactly should we be looking into? Okay, obviously the first of the things is what exactly is geomorphology made up of. Okay, when we say it's the science of landforms, what are the various land features that you would see? Okay, I'm saying features, I'm not saying forms. Okay, we are going to come to forms later as such. Okay, so you'll see that when we speak about forms as such, okay, you'll see that you have a river here, and you have the same river is looking differently here, and here is a land feature wherein you don't have any sense of water anywhere around. It could be there somewhere, but then it's compared to this and this photograph, you'll see that this is very unique. It's basically air dominated rather than this, and then you have water here again, but then this is saline water. We can see that this is sea, oceans, and of course here you have water in a solid format. So that's why it's a science. And you'll see that here, while this is the deposited form of wind erosion, this is the eroded form of wind erosion. So all this makes this surface of the earth so very interesting. And basically that is where, and or that is on what point basically where uh, geomorphologists get interested as such. When we study landforms, what exactly do we do, or what actually do we do? We try to study the origin. How does that particular, now all these 6 photographs in front of you, we would try to analyze each of them as to how, what leads to the origin of this particular type of landform. What, how does the formation, what is the development, what is the nature, and basically what is the process involved. As I said, that the processes are going to be different everywhere, and that is what makes geomorphology interesting. That is what makes geomorphology unique, and it's fun studying geomorphology as such. So when we study geomorphology, what exactly does this word mean? Okay, as I've just said a few minutes ago, that it's derived from the Greek word geo, or g. Okay, that's earth, and morphe means form. How does the earth form? And the earth's, the formation of the surf on the surfaces of the earth, the study of all these is basically the scientific study of landforms, the processes that shape them, and so on and so forth. It is a composite science. It's all put together. It's the study of landforms, including recent times, investigation into the processes and the causes that alter these landforms. So we know that the earth's surface is very, very dynamic. It keeps on changing significantly, and these changes need to be understood in a scientific way as such. Geomorphology is practiced with physical geography, geology, geodesy, engineering, geoarchaeology, geotechnical engineering, and so many sub branches of geomorphology into core geography, into engineering, and other aspects as such. Okay, so one of the basic things that we are going to come to, but then because the slide is in front of us, I would like to share with you all that one of the basic dichotomies that exist within geomorphology, even till today, is how the Earth was formed, okay, or what are the processes. When we say that these processes are happening around us, what is the origin of these processes? Now, some scientists have been believing that believe in the process of what is called as catastrophism, and some scientists believe in what is called as uniformitarianism. We're going to come to what these are, but before that, let us not get into all these complex aspects initially. Let us understand what is the importance of geomorphology. We'll come to catastrophism and uniformitarianism in some time from now. But when we speak about importance of geomorphology, it is to understand the geomorphological process in various environments. Say, geomorphic processes, let me tell you, in equatorial environments is going to be different. In urban environments, it's going to be different. In forest environments, it's going to be different. In grasslands, it tends to be different. In monsoon lands, it's going to be different. So these processes, and that's what makes geomorphic processes so very dynamic and so very interesting as such. Okay, you'll see that they adjust to the local environment, the local ecosystem. They get impacted, and so on and so forth. You'll see that as far as urban cities are concerned, when we are speaking about, and that is one of the important aspects when we speak about applied geomorphology. Let me tell you that when we in fact, I would say that when we hear of waterlogging in many parts of the cities, whenever you have some shower, you can immediately conclude that this is the failure of the study of applied geomorphology. Had you applied your geomorphology well, you would have constructed your roads properly. And had you constructed your roads properly, you would not have had waterlogging in different parts. It's not only roads, of course, construction of houses and societies and etc. Had we been very curious and cautious about urban geomorphology and applied geomorphology, we would not have that. So that's the importance of geomorphology. That I showed you photographs is just for interest. You'll see that a significant application of geomorphology lies in human systems. Okay, and why we are going to see further. Okay, you'll see that this next point in importance of geomorphology is to detect the natural environmental hazards efficiently. That's earthquake, flooding, landslide, tsunami, volcanism, you name it. And in fact, you should be able to link it to geomorphology as such. Then to identify various landforms, features, and landscapes, to identify various landforms from satellite images. That is the latest thing that is happening as far as geomorphology is concerned. That you don't have to go to Mount Everest to study Mount Everest. Okay, you just take a photograph of Mount Everest and the area around it from I won't say it's a photograph, it's an image. Now there is a difference in an image and a photograph. Unfortunately, you'll see that when you click a photograph on cameras nowadays, or on your mobile phones also, it gets recorded as an image. Okay, scientifically, if you go into the basics of that, you'll see that an image is different and a photograph is different. Okay, that is why we need to look into the dictionary meanings of image and photograph. We have taken it to be so very synonymous to each other that we are going away from the exact differences. And that's why I said that when you capture an image from a satellite, it's different to actual capturing of a photograph using a camera. Photo is with regards light. Now, image does not necessarily require light, okay, because it could go beyond the what is called as the electromagnetic spectrum also. Visible light, you have done this in your 12th standard, I think 11th or 12th standard, that the visible part of the electromagnetic spectrum is very small when you compare it. It's what, 0.4, from 4 microns to around 7 microns is the wavelength. Then you have the other ones here. You have the radar, and then you have the you have the X-rays and the alpha and the beta and the gamma rays. Okay, So on an image is where you could possibly be using any of these scanners to actually photograph it. Okay, but you cannot call this as a photograph because images can be taken up in night time also. So you're not using light as a consequence. Light, when I'm saying, I'm referring to the Vibjor part only, violet to red part, only that spectrum. Okay, so that's an interesting aspect to know about the difference between an image and a photograph. Anyway, going further, we go into coastal and river research and other forms of research, and something that is related to the second point, to detect natural and environmental hazards. Vulnerability cell. How much is a particular area vulnerable? When you say this area is prone to earthquakes, how much is the vulnerability? Because vulnerability will make you understand the cost of life and the cost of property. Okay, and that is why I would say applied geomorphology is getting very important these days, and that is why the basics, the nature and scope of this particular subject also needs to be understood in the real sense of it. Okay, so these are the importance. These are the importance. Of course, there are many, and when we go further, I would of course be discussing them one by one. We'll be opening up into each of them one by one as such. I keep this basically because I don't want to be monotonous here, and that's why I'm shifting to this particular thing. These are the various agents. Okay, river activities, wind activities, waves, and it's through this particular. We'll keep this in front of us, and we'll go into the nature and scope as such. When I speak about the scope of geomorphology, at what level do I understand geomorphology? I would say that say the dimensions and the scale of the relief features. Some relief features could be very literally microscopic. Literally microscopic. Say, for example, I have a heap of sand, and a drop of water is dropped into that heap of sand, and that heap of sand is just this much. I just take this and I put it like this, and it's on that heap of sand that I just drop of water. That also is a geomorphic feature. On the other hand, I have rain falling in various parts of the world, over the oceans, on the land. That is another scale. So from a very small scale to a very large scale, okay, we have to understand relief features in that extent. Now, what is relief? Basically, relief is of a particular area. You could have a relief for the earth, you could have relief for a small area, and that is what a geographer always has to keep in mind. Scale is very important. When you're explaining something to someone, you need to see that the person in front of you understands the scale at which you are speaking. So when I'm speaking about the whole earth, I need to mention the scale. Yes, I'm speaking about the whole earth. When I'm speaking about a small corner in my house, I have to say that, okay, the scale is that much. And remember, we spoke about large scale maps and small scale maps in our first or the second lecture. When you have a world map, that's called as a small scale map. Okay, basically because a larger amount of area is covered in a very small span there. But on the other hand, you speak about tourist map of Pune. That's a large scale map. You have large details in that. Scale is very important when we speak about the dimensions of relief features as such. Once you come to know that, okay, this is a large relief feature, this is a small relief feature, you compare them. Relief is the lowest point and the highest point. You draw a graph between them. Okay, of course, the land scale is also going to be there. So you'll see that when I speak about the relief of the Himalayas, I'll see that 8,000 meters and very near to it. Okay, let us say we speak about Darjeeling is very near to that. Okay, or you could say Kathmandu. Okay, if I'm going to join the points of height of Kathmandu and of course the point at which Mount Everest is, okay, the line is going to be very steep. That is going to be called as a steep relief. On the other hand, if you have been to beaches, okay, you'll see that there are hardly any undulations. For kilometers together, you could just have plain. And if I'm going to draw a line of the highest point on a beach and the lowest point on a beach, there would not be much difference. So relief is very important. What are the processes that bring about this relief? When I say the relief is steep, or when I say the relief is gentle, what are the processes? Is what is again a matter of scope as far as geomorphology is concerned. It is these processes that shape these landforms. You must have done weathering, you must have done mass wasting, you must have done rivers, you must have done wind, all of these. Okay, but remember that as far as these agents of erosion are concerned, agents of denudation, I would rather say, are concerned as such, Okay, you'll see that they are integrated. We study them for the purpose of simplicity in chapters, river work, weathering, mass wasting. We do them as chapters. But remember, all of this is integrated into each other, and that increases the dynamism as far as geomorphology is concerned. Okay, you'll see that you have all these processes, okay, landform shapes and processes are integrated into each other, and that's what makes the process a bit complex, I would say, but interesting equally as. And then approaches as far as geomorphic studies are concerned. How are we going to be approaching a geomorphic study? You'll see that I could be systematic as the pictures in front of you. I could be seeing the river activities. I would be studying only the rivers. We did this when we spoke about dualisms in geography, that system based. Okay, I would be speaking only wind and wind features. I would be speaking only wave and wave activities. I would be speaking only about glaciers and the factors. So that is systematic. I'm taking a particular system, natural system only, let me tell you. Then we spoke about it in multiple ways, in physical and human. Now we are narrowing down to a specific subject, that's landforms in the natural sense. And then in that case, when I say systematic approach, I'm either doing only rivers, I'm either doing only wind, I'm either doing glaciers, or I'm going wave activities as such. On the other hand, when I speak about regional aspect, when I'm doing India as a region as such, I see that I have the Himalayas separately, I have the Gangetic Plain separately, I have the Peninsular Plateau separately. All of these are different forms of landforms. I'm taking a particular region and identifying the various types of landforms within that. Okay, if I'm speaking about Maharashtra, I'm further going into the divisions of that also, that the mountains of Maharashtra, the rivers of Maharashtra, how have the rivers carved out the various basins in Maharashtra. It could be the Krishna basin, it could be the Godavari basin, it could be the Bhima basin, whichever one is there. How has it carved out is a regional study. So our approach to geomorphology could be systematic, could be regional. As I said, we don't have to be egoistic about me being systematic or me being regional. You choose whichever approach makes the subject easier to understand is what a geographer should handle. Okay, systematic study, as we have just said, that it includes geology, development of landforms. It includes materials. What are the materials involved in this? Okay, is it rock, or is it pebbles, or is it sand? What is the material involved in that? What are the forces which are pushing these things here and there? There are two types of forces. You have done this in your classes, and I would like to revise them with you all. You have endogenetic forces and you have exogenetic forces. Then you'll see that as far as these endogenetic, exogenetic forces are concerned, within them you're going to be you're going to have forces which are fast, very fast, and forces which are going to be slow. If you remember, when we speak about volcanoes and earthquakes, these are very fast processes. On the other hand, as far as faulting and folding is concerned, these are slow processes as such. So you could be looking at these forces in different way. You could either be speaking about endogenetic in the sense forces which come from the interior of the earth, and you have exogenetic forces. All the ones that you're seeing on your screen are in fact outputs of exogenic forces. So whether it is endogenetic, whether it is exogenetic force, one, whether it is fast, whether it is slow, two, whether it is local, something that is happening. See, these things in front of you are very local. Okay, the scale could be large, but then a glacier is located in a particular area. The meander that you see in front of you there is in a small area. The Barkhan or the dunes that you see in front of you is a localized area. So we could be speaking about on a localized scale, or we could be speaking about on a continental scale, or you could be speaking about it on a global scale also. So when I speak about plate tectonics, I'm speaking about huge continents, whole earth. Okay, but when I'm speaking about a meander, I'm speaking about a very localized area. So that you must be understanding how slowly it seems to be complex, but it tends to get interesting also, bringing so many things together and integrating things together to basically come up with a subject as interesting as geomorphology is something very, very fascinating. It fascinates me, and say gradually when you learn this, it will start fascinating you also. Okay, so it's that is what systematic study is all about. Then, as far as features and orders are concerned, okay, features, and when we speak about scale, okay, what I'm telling you is that a meander all the way to the Pangea. Okay. This is spatial scale, occupied space occupied by that particular object, and as a consequence, this is one type of scale, that is spatial scale. We did this also in an earlier lecture. And then there is temporal scale. Okay, you'll see that, and we have been doing something regarding the temporal scale till yesterday. Okay, the time span for the Earth to develop, okay, has been 4.6 billion years. But for a tree to grow, it could be a few months. In fact, for a seed to sprout, it could be a few minutes also. Okay, so from a growth of a tree to development, you'll see that as far as these sand dunes are concerned here. Okay, if you have ever been to Jaisalmer and if you have been watching these sand dunes, you'll see that trickles of sand keep on shifting here and there because of the gentle breeze that tends to blow in these areas. So you'll see that these temporal aspects, these are temporal aspects. You could be speaking about scale of a few seconds, a few minutes, a few hours as such. On the other hand, I could be speaking about a mountain, say for example, a mountain like this, which has taken thousands of years. So temporal scale is speaking about minutes and seconds on one hand, and as far as the other hand is concerned, we could be speaking about it on in thousands of years. So that is another aspect as far as scale is concerned: temporal scale and spatial scale. Spatial scale, space-based; temporal scale, time-based as such. Then, when we speak about scale of features, what exactly do we mean when we speak about scale and orders of feature? First order features. What would be, if I without explaining anything, if I say what would be first order features, what would you start thinking? What should first order be? Something that I see first, but where do I see first? Okay, where do I see it first? So we have to assume that we are approaching the Earth as a planet from outer space. So when I start approaching the planet as such, what do I see? I see the planet to be blue from a distant, from say a few hundreds of million kilometers or so. But as I approach, I start seeing the first features on the surface. What would be the first features on the Earth's surface? You will see water, you'll see land. So these are the features of the first order. What you see first on a very large scale are orders of in other scale. You'll see that this is large scale. When I'm seeing the Earth on a large scale, the whole of Earth together at a point of time, these are going to be called as features of the first order. Okay, when we speak about world geomorphology, we are normally referring to this particular scale. We are studying geography at that particular scale as such. A very broad view, I would not be seeing where is the Rockies and where is the Himalayas when I'm approaching the Earth from the space as such. But of course, when I zoom in, I would start to be seeing it as such. But world geomorphology, the first of the features on a planet, that's water somewhere and land somewhere. This is the first order. Then we come to the second order features. What are these second order features? These are nothing but subdivisions of your respective first order features. When I'm speaking about land, subdivisions of that, mountain, plains, plateaus, etc., are second order features. Okay, and of course, as far as water bodies are concerned, you may not be seeing it from above, but then dividing the ocean surface also into the continental slope and the continental rise and deep sea plains and abyssal plains and trenches, etc. All these are again second order features. Now, if you go into the details of that, formation of trenches, formation of continental slope, formation of mountains, formation of plateaus, formation of plains, all these, okay, they have internal forces operating into them, internal forces operating, endogenetic forces operating them. So the features relating to endogenetic forces, okay, earthquakes, volcanoes, folding, faulting, everything would be classified as second order features. These are classified as second order features. The third order features, when we study when we study geomorphology, the third order features are basically those which are related to denudational processes, features which could be weathering based, which could be mass wasting based, which could be river erosion, river deposition based, wind erosion, wind deposition based. All these features are going to be third order features. Now, let me tell you that it's very difficult to isolate them. Yeah, I could have a student who is immediately asking me, sir, how can do you say this? Okay, a delta is this, and it's you mentioned a delta in endogenetic, and however it's a depositional feature. As I said, there are going to be some gray areas, but on a very broad scale, first order features are the first things that you see. Second order are endogenetic features. Third order are exogenetic features as such. And all of these, endogenetic, exogenetic, always remember we have to keep in mind the spatial and the temporal aspects of these as now, having said this, uh, we come to a very interesting aspect. So we are coming to uh, probably we have understood what geomorphology is, that it's the science of study of landforms. But how do we study landforms? We have seen that we will be looking at the origin and the development and the processes that are dependent on the processes which are responsible and are dependent on these things that happen around you. Now, if I am to put all of this into a nutshell and to give you a very concentrated pill of understanding geomorphology as such, what could that possibly be? There was this American geomorphologist, W.M. Davis. Okay, he, whenever you speak about geomorphology, Davis has to come there because of his very famous, say, I would say quotation as such, but he gave us a sense of understanding geomorphology in a single sentence. I would rather say, he says that landscape is a function of structure, process, and time. Landscape is a function of structure, process, and time. So when I say it's a process, it's a function of structure, process, and time, what exactly does I mean? It means that when I'm looking at a landscape, what is any landscape? Now you would be looking at the first feature, the second feature, the third feature, the fourth photograph in front of you. Each of them is a landscape. Each of them is a landscape. So when I'm speaking about these landscape, river-based, wind-based, wave-based, glacier-based, whichever of them, they are a outcome of what? They are a function. Function means an outcome of what process? Structure. What has built up this particular feature? Any of these? What is the process operating on that particular structure? Okay, so if I have a land surface, I have some process which is operating, and because of that, I am carving out a river of that. Okay, however, that river, if I'm restricting myself to one of these only, okay, well, let us refer to one of these only. And let us say, because Davis has a lot of things to say with regards river, and the cycle of erosion is something that's one of the major contributions as far as Davis is concerned. That's why I've kept this way. So I would say that where is the river forming? It is on the land surface. Who formed the land? Okay, that's of course structure. Okay, structure meaning, is the surface hard? Is the surface soft? Does it have rocks? Does it have sand? Does it have igneous rock? Does it have sedimentary rock? What is the structure? Now it is on this structure that once a river starts flowing, that's the process. River is one of the agent of erosion. So from the type of land surface, something that is going to start carving that surface is going to be the process. And how long that particular thing is happening on that particular surface is time. Okay, so if it is very, very new, you'll see that the valleys are going to be V. If it is going to be older, it's going to be something like in front of you. Okay, you'll see that the river does not have that much of energy. It cannot erode anything that is in front of it. And that's why it starts taking curves here and there and here and there. And you can see this is the one of the most fantastic pictures you could see as far as meandering is concerned. You'll see you have the Oxbow Lakes behind that. Okay, and you'll have these curves which are taking place, okay, regularly. You'll see that right from the left hand corner of the photograph to the right hand bottom corner, the river is continuously curving because it's either in the second stage or the third stage. Okay, so any landscape, it I could explain this with regard to the second photograph, third photograph, or the fourth photograph also. Any landscape, it has to be, say, there has to be a base. The base for this landscape is the structure. There has to be a process on this particular landscape. This could be an agent of erosion. And of course, some time has to pass. So landscape is a function of structure, process, and time is one of the most fascinating sentences you could find by any of the scholars as far as geomorphology is concerned. That was given by Davis, and that's why you see that when I said, okay, I meant this when I said that the moment you speak about geomorphology, you within first 5 minutes, you come to the name of W.M. Davis. There's a very interesting story about why Davis gave the cycle of erosion, etc., etc. We're going to come to that also. If I forget, please remind me of that. Then, when I'm speaking about approaches, how are we supposed to be approaching these studies? Okay, I know I have to study the structure. I know I have to study the process. I know I have to identify the time that has lapsed as far as processing of that particular land surface, that structure is concerned. But how am I going to go that? Okay, you'll see that I could speak about, I could have two approaches. I could have a historical approach. I could have a functional approach. Okay, historical is just describing it. Functional is actually seeing what is happening in the sense the landform and of course the environmental conditions. In the sense that where am I going to find meanders? I don't find meanders everywhere. Where exactly am I going to have? So that's going to be functional. Okay, where do I find uh, dunes? Okay, I don't find sand dunes everywhere. Where do I find glaciers? Am I going to find glaciers everywhere? No, I'm not going to find glaciers everywhere. As a consequence, I have to be very functional. In which environment am I going to find these geomorphic landforms? Is one approach I could have. The other one is historical. I could just be say just like writing history about man. We could write history, geography about the history of geography. I would rather say, as far as landforms are concerned. When we study this, what these approaches as such, what are the various approaches? The first of the approaches is description. We tend to describe the geography of the landforms. We tend to describe. Now, this description also is of various types, in the sense that the description could be subjective. In the sense, it could be related to an individual. I see this thing happening in front of me. For example, if I don't know how many of you all have observed the photograph which I have placed for today's thumbnail as such, but if you see, you can see a tortoise in that. If you have seen a tortoise, thumbs up. If you have not, now you go back and see it's a tortoise. Now, why do you see that tortoise? Because I asked you to see the tortoise in that. If I had not asked you to see the tortoise in that, you would have not seen the tortoise in that. I want you all to look into that photograph later after this, and then report on the WhatsApp group that whether you had initially seen the tortoise, and then whether after I have asked you to see a tortoise in that particular feature, have you seen a tortoise in that? So subjective. Okay, descriptions could be subjective. Somebody sees something, and that is why. Okay, now just imagine we speak about V-shaped valleys and U-shaped valleys. Somebody who is not knowing English, how will he see a V-shaped valley? He will not call it as a V-shaped valley. He will not call it as a U-shaped valley because I don't know English letters. So it's very subjective. So subjective approach is a bit dicey, but then this is the layman's approach. भाई मुझे तो दिख रहा है वो आपको दिखा रहा हूँ. That is how it goes by. Okay, so that is as far as subjective descriptions are concerned. Then you could have genetic descriptions. What are genetic descriptions? Genetics is basically going into the roots of everything, isn't it? You have that genes and what are they called as which acids, I don't know, which make up the DNA matter and so on and so forth. You're going into the causes. Okay, so when I'm going to genetic description of a meander, I go into the cause as to why is this happening. When I'm going into the genetic description of a sand dune or a glacier as such, I look for the cause and effect as far as these features are concerned as such. And finally, I have objective in the sense I say it's very methodological, it's very mathematical. I will look into, I will format some equation that, okay, the curve is at this particular angle, the amount of water is so many liters, or the curve on the sand dune is so many things, that this is the tan theta, this is the cos theta, and so on and so forth. So I would be using abstract equations to solve my queries as such. I would be using abstract methods, okay, finding x, finding y. It could be actually finding x and y, or it could be probably finding x and y. Why I'm saying this is because when I'm actually finding x and y, I'm using mathematical terms. when I'm probably finding X and Y, I'm looking into statistics as such. When I'm using these methods of quantification, mathematics and statistics, okay, I would be looking at having a objective description as such. So subjective description, genetic description, and objective description is something that is one of the approaches that we have. The second approach is a classifying approach. We tend to see this and we classify. Now, how do we classify? We compare and contrast. Okay, we take a particular feature, features which are similar to this. Okay, this one is similar, so this is this. This is not similar, so this is separate. This is halfway similar, halfway, so this is another classification. So 1, 2, 3. I've immediately classified features into three various aspects as such. So when I speak about um, classification, these could be again quantitative classification, in the sense that when I'm speaking about mountains, I would be speaking in terms of the slope of those mountains. That very steep is nearly 90 degrees, less steep is 80 degrees, gentle slope is going to be 45 degrees, very gentle slope is going to be say 10 degrees only. So when I'm quantifying that amount, that is a classification. So I would be classifying all slopes or all hills which have a slope of 10 degrees. I will be classifying all hills which have a slope of 45 degrees. I would be classifying all hills with a slope of 80 or 90 degrees. So that is the way of classifying features. As I'm just giving you examples. So quantitative, and then genetic classification. As I said, that this is a river feature, this is a glacier feature, this is a wind feature, this is a wave feature. Okay, so I could classify genetic, the cause of it as such. Okay, so that is another thing as such. And the third one is explanation. I go on explaining what in a scientific way. I go on explaining how this. So these are the three basic approaches as such: description, classification, and explanation. Okay, so that's a very interesting thing to have that we have noted about it as such. Now, coming to the history of geomorphology, how did this study, and rather when did this study start? Okay, you'll see that as far as present writings are concerned, it's not very old. But if we tend to relate it into ancient times, yes, people were thinking, they may not have called it geomorphology then, but it could have been a part of geography, because we know that Eratosthenes had called this word in a few centuries before Christ as such. So geography was there. Probably they were not studying geomorphology that intensively, and as consequence, you'll see that we need to see how that has developed. You'll see that in ancient times you have Herodotus. If you remember the initial slides, I gave you scholars of the ancient period. Herodotus was one of them, and he in his works he speaks about the river Nile in Egypt. Okay, he speaks about the delta of the Nile. He speaks about the flooding of the Nile. He speaks about the waters retreating of the Nile. And what is more interesting is towards the delta of the Nile, what he did is he tried to identify fossils. And as far as these fossils are concerned, he started classifying them. That whether these fossils are riverborne or whether these fossils are seaborne, that's from the Mediterranean Sea as such. Now, if on an upper course of the river, you find a marine fossil, that means at some point of time, the sea level was high. On the other hand, if you find some fossil related to the river into the marine environment, you would say that possibly the sea levels were down at a particular point of time and the river was coming all the way till this particular level. Now, it's of course not as easy as I'm saying it. You have to have a lot of analysis into that, scientific analysis, at least as far as to date is concerned. But we know that Herodotus was not only speaking about the floods of the Nile and the delta of the Nile, which part is fertile, which part is not. You also spoke about transgression and regression of the sea levels along that particular coast. So this is a very interesting thing. Remember, this is happening 2,000 years ago. So it's so very significant, similar to Eratosthenes measuring the circumference of the Earth as such. Measuring the circumference of the Earth is what I would call as a quantitative approach, okay, using geometry, etc., etc. Okay, so that is as far as Herodotus is concerned. Then comes Aristotle. Aristotle speaks about the sources of water. Of course, he saw that uh, uh, there is no rainfall, but then you have water in the rivers, in some rivers. These are called as perennial rivers. What could be the reason? He said that there are some springs which add to the source of the water in the river channel. So this was another. Remember, these things are happening around before Christ. Before Christ. So that's the significance. Nowadays, it could be an easy thing to analyze for us, but then at that particular point of time, these were initial explorations into geography as such. Then he also speaks about the fact that as far as limestone topography is concerned, चुनखडीचा प्रदेश आपण ज्याला म्हणतो, limestone topography, in limestone topography, you don't have water flowing on the surface for a very long time. We later realized that in fact water dissolves limestone and then it starts growing underground, and that is called as karst topography. Okay, this is what was identified by Aristotle in those days. Okay, two things. Basically, springs feeding the source of water in river channels, and secondly, limestones do not run on the surface, or they do not have much of surface drainage. They have a drainage which is under the surface, underground surfaces. Okay, then you have another person by the name Strabo. He speaks about depositions more. He speaks about he very nearly comes to a concept which came much later. That's called as differential erosion. Okay, in the sense, what is differential erosion? Okay, the agent is the same. The amount of water, the slope, everything of the river is the same. But it so happens that in some areas the erosion is more, in some areas the erosion is less. Why does it happen? It happens basically because of the structure. If the structure is of igneous rocks which are hard, obviously the erosion is going to be less. On the other hand, if the same river is flowing on a sedimentary surface, the erosion is going to be faster. Which of the sedimentary rocks is there? All this makes it so very interesting that it's whether it's hard or soft rock will decide how much erosion is going to take place, with all the other parameters remaining the same. And this is called as differential erosion. He did not coin the word differential erosion, but he seemed to be speaking about these aspects, that some deltas are different shape, other deltas are different. That's very interesting observation. Again, reminding you, these observations are happening 2000 years ago as such. So you'll see that this is something which was happening till the time of Christ. Okay, for 3, 4, 5 centuries before Christ, till the time of Christ. But from the first century, for the next 1400 years, you'll see that not much was happening as far as geomorphology is concerned. And in fact, otherwise also, those of you all who have studied history along with other subjects, or who read history as a liking as such, will know that these ages are called as the dark ages. Dark ages as such. Nothing much as far as scientific development seems to have happened in this particular age. It's only between the 6th, 7th, 8th, 9th century that you have some activities as far as the Arab world is concerned. Okay, you have some Arab contributors who made significant contributions in learnings of geography also, but not much. It's only around 1400, okay, the 14th century, that things start changing again. Okay, there comes what is called as the age of catastrophism. What is catastrophism? Let me, where did I put it? Um, sorry. Yeah. Where did I put catastrophism? Just let me see. Yeah, this is catastrophism. Yes, I did tell you all that we would be coming back to this. And this is catastrophism. I hope you are able to see this, and I have not gone to, let me see. I'll just wait for some time. Okay, I'm seeing that you are having a lot of conversation amongst you all. Yes, we are going to shift to Google very soon. We are nearly finalizing that process as such, but yeah, we'll come to that. Let me just, sorry. Just give me some seconds. Yeah, here we are. Okay. It was in around 1400 that the concept that the Earth was built with a lot of catastrophic activities came forth. A lot of catastrophe, and that's why this concept of catastrophism comes to fore. Now, what is catastrophism? No, of course, it was not suddenly that the people started speaking about it. They saw a lot of earthquakes happening around them. They saw a lot of volcanic activity happening around them, and as a consequence, they thought that, well, the Earth's formation has happened out of all of these earthquakes and volcanoes, which are very catastrophic activities because they're destroying life, they're destroying property as such. And as a consequence, you will see that catastrophism came to be formed. Now, it's not directly that people started speaking about catastrophism. You'll see that it had been there in discussion in the 12th century. It was there in discussion in the 13th century and the 14th century also. But after 14th century, this concept started catching a lot of attention, in the sense that the origin of animate and inanimate, that's natural and biological elements on the surface of this planet, was very sudden. Okay, that's why the word catastrophism comes in. Okay, events tend to happen within one's lifespan is what catastrophism was reflecting at, and that is why during this particular phase, I would say the age of the Earth was estimated to be a few thousand years, 6,000, 7,000 years, as such, because they said that all these things have happened very fast. Okay, so that was what all catastrophism was all about as such. But okay, gradually, this gave way to what was called as uniformitarianism. Now, what is uniformitarianism? We refer to the name James Hutton, okay, when we spoke about the geological time scale. Hutton, in the 18th century, just imagine, for 4 centuries, people were believing in catastrophism. Of course, there are people today who don't believe in uniformitarianism. They still believe in catastrophism. But it was James Hutton who was referring to the age of the Earth. If you remember, I said that it was Hutton who said that it's not a few thousand years; it could be a few million years that the Earth is old, has been old for. Okay, so he says that what uniformitarianism means is, you can see it in the center picture, that Hutton speaks about the theory of Earth in 1788. He says that the processes that are happening around you today have been happening before you, will happen after you have gone. It is not a question of you living and you seeing things around you. Things have been happening before you and things will happen after you. The processes on the Earth are uniform. They are governed by scientific laws, and as a consequence, say these basic laws have been there in the past, so they have been affecting landforms accordingly. They are there today, they are affecting landforms accordingly. They will still be there tomorrow, and with a bit of dynamism as such. And that's why I've just purposely put this for to explain uniformitarianism. You'll see that you are going to have rocks, they are going to come out, and you're going to have volcanoes, and then you have upliftment of surfaces, you have metamorphic rocks, and you have sedimentary rocks, and so on and so forth. All these depositions will take place, and there are going to be transportations and so on and so forth. So the processes have been there in the past, and they are going to be there in the future also. So catastrophism, which was very strongly discussed and advocated for 400 years, now gives way to uniformitarianism. What is the difference between this? Catastrophism, that's towards the right of that particular center thing. Most say all geological change occurs suddenly during catastrophes. Earth is only a few thousand years old. This was the basis of catastrophism. But then uniformitarianism says, okay, starts with Hutton and then Charles Lyell. He continues with his in principles of geology, that these are gradual geological or say geographical processes. Erosion, deposition, mountain building are an outcome of these uniformitarianism processes, and most importantly, that the Earth should be a few billion years old, at least. As I'll be stopping here today. I just came down back and I saw that there have been a lot of questions, so I would like to take those questions as such. Uh, Okay. Uh, Sir, screen is not clearly visible. Screen is. Oh. The problem is while sharing screen, sir is not able to see the chats. Oh, yes. Oh, so you all had a discussion. So sir won't get our problem at the end of at the end. Sir goes through these chats. Yes. Oh, okay. Yeah, he will. Uh, I'm trying to get the words and write. Okay. Now, Akshata says, sir, I think I missed that part, but exactly geomorphology means as a definition and the meaning. We did this in the earlier section of this very lecture. Then, sorry, exactly, I missed the same definition and sort of information. That one side I is missed by me also. I was not able to read. Don't worry, I will share it later. Okay, that's good. Thank you. Radhika again says, I think we should suggest her to have a lecture on Zoom or Google Meet so that we may have conversations. Yes, very soon we are going to go into that as well. And yes, actually, I also think the same. Yeah. Yes, there are some problems, it seems, as far as the clarity is concerned. So, say by next week, I should be coming up with a class for us, and next week onwards, your attendance also will be recorded because we are going to use a licensed copy of Google. So I could be able to monitor what you are doing and what you are not. Okay, so well, that's all for today. We stop at this concept of uniformitarianism and catastrophism and how these are so very opposite to each other and how the development of one leads to understanding. You'll see that it's not that we can strike away catastrophism absolutely, neither can we do away with uniformitarianism. As I said, these were the ages wherein you had what we refer to as subjective type of interpretation. So uh, we'll go into the details of that. Probably by next week we should be shifting to the Google platform. Let's hope for the best. Most well, 90% we will be shifting to Google platform. So all these issues should be solved. That's all for today, and we'll stop here. Thank you very much for being there. Stay home, stay safe till we meet next time.